Okay, so let's create a Kubernetes cluster, and we are going to do everything from the web console of Oracle Cloud. So you should see something like this, where you have the region that you are going to use. In my case, it's my home region, that is Frankfurt, but you can use any of your available regions. In my case, I'm going to the menu, and here, let's scroll down until you reach developer service. On developer services, we have several services. One of them is the Kubernetes cluster. Let's dive in. And here, at the moment, in my compartment, I don't have any cluster. I'm going to create my first cluster. Click on the button, and then we have two options. One that is the quick create, that is the one we are going to use, because by default is going to create your virtual cloud network, all the networking that you need, with the gateways that you need for connecting private and public subnets, and also the Kubernetes cluster and your worker nodes. All in one go, super simple, easy for mocking, for creating a proof of concept, and just start playing around with Kubernetes. That's why we are going to choose it. If you want a production environment and you want to tweak specific things the way you want, you click on custom creation. That is going to only create the Kubernetes cluster and the worker nodes. Everything else should be created the way you want and reuse it. For the moment, quick create, launch workflow, and it's going to ask for specific information. In my case, cluster name, I'm okay with cluster 1, the compartment that you want to create the cluster on, the version. We have always 3 available. The latest is 1.16.8 at this moment, but we are updating the Kubernetes cluster we are following more or less 1 version behind or 2 versions behind the Kubernetes latest version. You have 2 options for the visibility of the worker nodes in our case, and I recommend always to create private worker nodes in a subnet that is private, but you can also select public if that is the case or what you need in this case. Then the shape. In the shape, you need to choose one. For testing purpose, you can select one of the smallest versions that we have. So I recommend you to go for the virtual machine standard E2.1 that contains 8 gigs of RAM and 1 CPU. And then it's asking for the number of nodes, and the number of nodes in my case is going to be 3. You can definitely change that to the number that you want, but initially for testing purpose, 3 is kind of a standard good number. You can specify different custom volumes, that is kind of advanced options, and there is other advanced options like your public SSH key in case you want to connect to your worker nodes for some troubleshooting. At the moment, I'm going to leave it as it is. Remember that if it's a private node, then you need to set up a bastion host, and there is some information here if you want to go that way, and you can even label your nodes. For the moment, I'm okay with the standard options. We click next. We double check that all the information is the way we want, and after that we click create cluster. This is going to start creating the networking, the gateways to enable communication with internet and internet through a private subnet. It's going to create all the associated networking components like route tables, security list, subnets, and it's going to start or initiate the creation of the Kubernetes cluster, all the master nodes, all the setup, the machinery that is needed for Kubernetes, and also the node pool. So we can close here. It's going to take us to the detail page of the Kubernetes cluster. This is going to take a few minutes. I will use that time just to explain a little bit what information is available here. So as you can see now it's gray until the Kubernetes cluster is enabled, but you have a way to, some instructions to connect with your Kubernetes cluster with kubectl. you can upgrade the Kubernetes cluster master nodes. So basically that is a zero downtime upgrade of the Kubernetes cluster. Basically, we are in 1.16.8 and there is a new version available, 1.17 something. In that case, you can click there. You don't have access to the API of Kubernetes, but all your worker nodes will continue with your application with zero downtime and no issues. That is as simple as that. Click a button, you have your Kubernetes cluster updated. I will explain later how to update the specific worker nodes, but initially this is for the master part. The master part on Oracle Cloud is something that you don't pay for, so you only pay for active worker nodes that are going to execute your application. Everything else, Oracle take care of that. So that is really interesting because it reduces the price of your Kubernetes cluster. And basically the only thing that you are going to pay is for the CPU of your nodes, the block storage and file storage that you reclaim with a persistent volume claim, and the load balancers or all the networking specific services that you are creating to support your application. Specific information, Kubernetes cluster, Kubernetes version, the address that is not available just yet, some pod security in case you want to implement pod security. It's not enforced, but you can modify that. You can also encrypt the information that is stored in etcd, the database that Kubernetes is using. That is something that you can do with the Vault service that we have in Oracle Cloud. It will tell you who created this, when, what compartment is, and the cluster ID. That is basically a unique identifier inside of Oracle Cloud that allows you to specify and use the console, the command line to get information from the command line and so on. It's going to tell you the status, and we can scroll down, and at the moment we don't have information. I can show you a Kubernetes cluster that is up and running with all the information you get, but well, it's all the API server request, response, and schedule pods that is going to give you clues if you need to schedule new worker nodes. You can filter by start time and end time, and if we go to this small menu on the left, we will see that we are on metrics, and we can jump to node pool. In node pool, it's going to tell you that if you want to access the private nodes, as I mentioned before, you will need the public SSH on the nodes and also to set up a Bastion host. And once again, there is a link with documentation on how to do that. We have already our pool with this version. In this case, is the same version as the master node. And in case we want to update that version, that part, and it's already jumping into active state, so that's great because we can continue with the demo. In order to update that version, imagine that we move the master nodes to 1.17 and we want to move the nodes. There is two approaches, but it's the same functionality. Basically what you do is to create new ones and then drain the old ones, so all the pods are migrated to the new ones with a new version, operating system patches, everything is a new version. Then you drain the old ones, and that means that at some point you can deprecate them. That is one way. The other way is that you can grow one pool. Instead of creating a separate pool, you can grow this pool with another 3 nodes and then do the same approach. Drain the old ones, wait for the new ones to have all the workload, and then you can delete the old ones. If we jump into the pool, we will see specific information about the pool. In our case, it's active already. It will give you information about the availability domains for high availability, the subnets that they are connected with, and also some metrics on the state of the nodes. And you can even see the nodes. So this is the nodes. As you can see, they are still updating and getting provision internally, but they are already created. We come back to the cluster. We have something really important, that is the work request. So everything that happened on the service. We start with the cluster creation. and then we jump into the node pool creation. So everything that happens in your cluster will be here as a history of actions. And then we have the quick start. So the quick start is just a helper for you to start playing around with Kubernetes cluster. Let's click there, and there is two options. One, if you have to use your kubectl on your local environment, on your machine, you click there and you have all the options, everything that you need. So as a requirement, you have the OCI CLI in a specific version. You have to use that, configure it. You have links to the documentation there. When you are happy, you should be able to run this to know the version of the OCI library, the OCI application, and then you start creating the folder for the configuration of your kubectl, and then you run this command that is going to give you all the kubeconfig that you need to talk to your Kubernetes cluster. And that is all. In this case, we are going to use something really interesting, that is the Cloud Shell. So Cloud Shell is a shell that is embedded in your web console. So we are going to launch it. You either click here, but the traditional way as well is to go here. I'm going to click. It's going to start spinning a small virtual machine that is free. It's not part of the services that are going to consume your budget. And it's basically a small virtual machine that has a lot of tools already installed that allow you to talk to Oracle Cloud, to like the OCI CLI. It also has kubectl, it has Python, Node, and some other languages that you can start creating your scripts or play around. And it has direct access to your cloud. So it's kind of a really handy way to just start talking to Oracle Cloud from a console, like if you were on your local environment. So let's wait for that to spin. And after that, we are going to run this command. So I'm going to copy and run it here. So as you can see, this is just a Linux machine with all the capabilities. It has like 5 gigs of storage that should be enough for you for doing testing and create some proof of concepts. I'm going to paste that, run it, and after that we should be able to run kubectl to get our nodes. Okay, so let's say kubectl, and we are going to get the nodes. This might work or not depending if the nodes have been fully provisioned, so I'm going to run it and see what is the result. I also check that, yeah, for example, there is no resources on the default namespace. So that is a way for you to check that kubectl is working, that is checking the version, and that is going to tell you the version of the local. We are talking about 1.16.13, and our Kubernetes cluster is 1.16.8. So we already have connection with the Kubernetes cluster, and what we can do is close this, and we are going to go to the next step, that is deploy an application. You can run that command that basically is going to go for that deployment. Let's check if that is available. I'm going to open another tab, I put it here. It's already downloaded, so it's available, and let's execute it here. So I'm going to copy this, running on my console. Let's actually clean it. And now I'm going to execute that. And that is the way you can deploy your application. It's already created, so if we do kubectl get deployments, we can see that we have a deployment that it has 0 of 2 ready. If we check this in few seconds, we will see that it's available, everything is up and running, and we have deployed our first application in Kubernetes cluster. Super simple and nice thing to do to test your account. And that is the 2 pods that we requested on that specific deployment. So let's test something else, that is, let's get that file. Now we have the deployment. I'm going to open that, maximize the window of the terminal. That's good. And then we are going to open that file. And as we see, we have two replicas of an Nginx. That is the two containers, the two pods that we are specifying here. There, Nginx and Nginx 1 14